Yeah, I don't think it really adds something that you didn't already have. I mean, I can demonstrate, oops, slow motion. I can demonstrate standing wave. I think I have some of these values memorized. Um, so, okay, normal, no damping. Um, this is a kind of a standing wave that you have when you have both ends fixed at the end. Then you get the nodes at the end, and this is the frequency that will give you the fundamental mode. You double it, 0.85, then you get that different shape with the node in the middle here, additional node. And you can, this is the first harmonic. You can get the second harmonic by tripling the original frequency. That should be 1.2, technically 9, but I'm gonna kind of handle a bit of a rounding error, so maybe, I don't know, 8 or 7. So this one has, this is a standing wave with 2 nodes in addition to the nodes at the end. Now, one thing I want to make sure you are aware is that for the lab that you're doing, the setup leads to not boundary conditions like this, where both ends are nodes or both ends are antinodes. It has a boundary condition where one is a node and the other end is antinode. On a string, on a wave on a string setup, the way to get a condition like that is to use the loose end. And when you use the loose end, the entire shape of the standing wave is going to look different. So these frequencies that used to work actually will not work anymore. If I go back to 0.43, it won't work. Now, what will work is, so for 0.43, we fit half a wavelength into that length. And when you study the shapes carefully, the lowest frequency that will fit within the boundary condition of the node at the fixed end and antinode at the ring end is going to be half the frequency, so that we fit a quarter of a wavelength within that length. So let me bring this down to 0.22, I think. And it's gonna take a bit of time to build up. But now you are actually seeing standing wave build up. This is a quarter of a wave. The next harmonic won't be double this because you have to fit 3/4 of a wave. So I need the triple of this frequency, or 0. something like 66. And so in the lab, you'll be able to set up standing waves like this. Now, they won't be visible because, it's sound wave. But you will be able to hear that you have a standing wave in terms of increased sound because due to resonance. Let me just go one higher frequency up. So that's going to be 5 times the original fundamental frequency. So it's I guess 1.1-ish. It's because of rounding error, it's going to start to go a little bit off, but hopefully it's close enough. Let's try it. So this should have fit at least one wavelength. You can see it here. So starting from node, node, node. So that's one wavelength plus a quarter. Now, one reason I was hesitating with this was in your lab. So here I'm varying the frequency. Your lab was designed to vary the length of the medium, keeping the frequency the same. I think yeah, so just make sure you are clear on what you're keeping constant and what you're varying. So I think that's all the time I have.